Hey, thanks for the invite to come and talk to you about an industry that I care about and actually enjoy working in. I've always loved doing what I've done since I started 12 years ago. So I'm here to talk about a little bit about the STEM as a whole. As we all know, science and technology is constantly around us. It's ever growing, ever evolving, and at a very rapid pace. And then the engineering portion, is basically like how we build things to accommodate that kind of technology, which is really great. And a lot of that is a lot of team effort, individual effort within a company to make things happen. And then math, it's a tool you use while you're doing your engineering to build things, to design things, to develop things, to teach people. So it's very all important in this field that I've been lucky to be in for a long time. So, whoops, sorry. So I'll talk a little bit about myself. My name is Jim Milbauer. I actually live in Vermont still. I stay in a residence here during the week, go home, spend time with my family during the weekend. So it's a great opportunity ULC has given me to do that. I started working in manufacturing of optics as a diamond turning technician. I was second shift, didn't know anything about optics. And then kind of grew up in the field. A diamond turning machine is basically a high-end lathe. It's down to the nanometer resolution, and I cut certain crystals like germanium, silicon, crystals and stuff like that, which is really cool because some of the materials that you use are actually grown in like a mine. In Utah, they grow them in a cave, so it's really neat stuff, and calcium and stuff like that. So it was really neat, and that was more in the infrared. I moved on to become a metrologist from there, where I actually measured lenses using interferometry, which is a certain method of using light to bounce off a surface to give you a peak to valley, basically like a smoothness of that surface. So it's really neat stuff. And then I became a supervisor and kind of oversaw diamond turning and metrology and CNC polishing. And then I went into, because I pretty much touched everything within the company as far as whether I assembled lenses or I made them, and then I became a manufacturing engineer there because I had to understand the process. So it was really interesting stuff. And then I had an opportunity to move as more of a manufacturing engineer / quality engineer because I got real fascinated with statistical process control, SPC, which is very interesting to see trend data and how it correlates to where a machine functions and where it stops. Because let's say you have like a curve like this, and in that curve there's a portion in there that your tool or your machine will make the best product that it will in its lifespan. And the statistical process data shows you when that's happening, so you can decrease the amount of quality measurements that are needed to make sure that product meets what the customer requires, because it's at its best life. And so that's what really fascinated me with the quality aspect of it. So I decided to become a quality manager and was offered a job to become quality manager, took on that role and implemented certain things to help maintain that. So that's pretty much about me. If you have any questions, I can tell you more of what I did later on. But like I said, I've been real blessed to do this kind of work. I've enjoyed it. And I'm sure if you guys choose this, it'll be a lot of fun too. So what is the optical industry, right? What is it? When people think, optics, they think eyeglasses, right? Well, that's a very, very small portion of actually what happens. So I picked some things that I've actually contributed to in my time in the industry that I made. Military, obviously a lot of the things that we all use every day now started probably as a military funded thing, whether it's our iPhones or whatever. So military was key. I was able to be on a couple programs like the DVE program, Driver Vehicle Enhancement Program, which was really neat, through DRS systems. And what that allowed was we made 2 germanium lenses, diamond turned, the whole thing. A couple of them had A-spheres, I'll talk a little bit about that. And they got put into an assembly. And what that went on is it went on the front of a Humvee for our soldiers, and they were able to drive at pitch storm, black, couldn't see anything in front of them, sandstorm, whatever, and they were able to see up to, I think, 60 feet in front of that vehicle while driving at 45 miles an hour and see landmines or IEDs or things like that. So it was pretty interesting. That's just one example of some military type things. Also the handheld thermal imagery, HTI, which was really cool. It was very similar to the DVE program, but it was for soldiers in the field, and they could tell, and this is what I really liked about it, is they could tell when a landmine was placed up to 30 hours before. It left that much of a difference, a heat signature, because we're talking about infrared, you know, because even though the desert's hot, there's still a different signature between every type of material that gets placed there. Aerospace, done a lot of fun stuff for that. A lot of stuff that goes up in the space, you know, or may not go in the space, or is a design that was funded through NASA or whatever. But you know, we made certain wafers and stuff like that that might help gain energy for a satellite, and kind of real cool stuff with that. Bioscience and medical. When I was a quality manager at a company in Massachusetts, we did a lot of stuff for endoscopes. We did what we called micro optics, which are really, really tiny optics. Like, you got to hold them with tweezers, you got to inspect them under microscopes, and they went on to the end of endoscopes, like a company that's close by here, where you know, if you had neck surgery, they would go in. They, you know, very invasive, right? They won't have to cut you way open, kind of thing, and they just kind of go in, and they're able to use that camera to prepare it. So those little tiny cameras got to have lenses in them, you know, optics in them. So that was pretty neat. Commercial, some of the, especially, you know, even now, United Lens, we make stuff for like the 3D camera industry, for the laser industry. We make debris shields to protect a lot of the high-end optics that are in these, which is pretty interesting. Or, you know, you see a lot of electricians now, right? They got to check hot spots when they go inside electrical panel. They use a lot of thermal imaging and stuff like that, to see if that transfer is hotter than it should be. You know, another example of that is like when they, instead of changing out an engine in an aircraft, right? Because it gives off certain heat signatures. So if the bearings are wearing, it gets hotter. So instead of taking apart and spending who knows how long on changing out an aircraft engine, they're able to determine using some optics if it's at a certain temperature to just rebuild the, you know, before they were just doing it by time and not what it was actually doing. So lasers, a lot of the optics, you know, lasers gets created, goes to like a focal point. So you need lenses to be able to create that energy, you know, kind of like an ant with a magnifying glass, right? You know, that kind of thing. And so what is optics, right? It's pretty much all based on physics. I'm not going to say I'm a physics guy or anything, you know what I mean? So, but it's how light behaves, and it's how we use it as a tool to, and control that behavior, which is pretty neat. And I'll go over that in a little bit. And most people, like I said, think of optics mainly as either eyeglasses or like telescopes. Now that is a portion of it. If you want to see Saturn's rings or whatever, you know, there's optical glass in there. And you'll find it's everywhere. It's in your phone. It's actually in the projector right now, projecting. You know, that's what optics does. You'd be surprised how far of a reach it has, you know. Whether it's cameras filming movies, or like I said, the projector, your phone, your watch, anything that's giving off any type of image usually has optics in it, you know. So, you know, when you Skype your girlfriend or boyfriend or whatever, you know what I mean? There's optics in there, you know. It makes you see it. So what is optics? Well, there's a whole spectrum that the human eye can see, right? And so pretty much from 400 nanometers to 750. And when you've been in the longest as I have, you'll understand it a little bit better. But so basically, this is the range of what your eye can see as far as light. You know, ever see like the rainbow when you look at a pond in the water, kind of thing. That's what you're able to see. Then you get into infrared, where your eye can't quite see, where you use certain materials, you know, to project. Like, you know, how many times have you guys seen, you know, the cops running after somebody and then they see this figure, but it's like blue or red. You know, they're using infrared imaging to capture that. Then you have ultraviolet. So some materials have a certain reflection or transmission based on the material by itself. So we actually apply coatings to that in this industry to actually enhance that reflection or enhance that transmission, you know, that to be able to see something further. So here's an example of like an assembly. Something like that might be in this projector. Might have multiple lenses in it. So you have a source here, which would be your camera or light source. And then that source that gives off that energy or light, it actually produces through this optic and either converge or diverge based on the shape of the optic. Here you have a plano, convex, and then a biconvex lens. And then you see how that light changes shape as it hits that surface. And that material also impacts how it changes the course. And then it goes here, and then based on how it comes through here, it focuses to certain points. And that's called a focal length. So that's no different than the camera, like the gentleman taking pictures right now. He's got a focus, and by changing the gap between these lenses, by doing that, changes your focus point as well. So that's very, basic stuff. Can't say I know much more than that, you know what I mean? But it's pretty cool stuff, And based on the material, it changes and things like that. That's why, if you own a camera that has an F lens, right? That's basically your focus number, It's called the F number, focal point. So that's a little bit of brief on kind of what optics does. Pretty neat stuff. And then the manufacturing and the going in that could be polishing, CNC polishing using CNC machines. Could be diamond turning. Could be double side polishing, continuous polishing, CP polishing. So there's a lot of methods to learn to be able to do that, and it's a lot of fun. It's a lot of fun learning all that. So United Lens, as you all know, we're right down the street. It's a pleasure to work for them. From my personal experience, I can say that. We've been around since 1916, long time ago. We're actually celebrating 100 years soon. And it's been under the same ownership, same family has owned it, which is very unheard of nowadays. And it's very diverse, right? Very diverse, does a lot of different things, reaches out to a lot of different companies in the industry. They started off as molding lenses for glasses, like you traditionally think. And Felino de Gregorio started it with just one furnace, because they particularly worked on molding lenses to give the optician to be able to create what they needed to make. So it started off with molding glass at an extremely high temperature that makes that glass more malleable to manipulate in the mold. So as more furnaces were added to keep up with the demand, because it became a real hot business for us, and they constantly improved quality with fast turnaround. That's real key for us even today, is our fast turnaround with outstanding quality. There's very few people that can deliver as fast as we can and maintain the quality requirements that a customer requires. So the result of the company, we were called upon during World War II to produce molded lens blanks for many instruments. A lot of the standards that are used today to manufacture in most industries are all based on mill standards that started back in World War II, and then were constantly changed as the technology changed. But a lot of the things that we manufacture to are still based on specs based on that. So in the mid-70s, we had a big expansion into what is now called Optical Shop, but it's optical fabrication. We perform a lot of close tolerancing, extremely tight tolerancing precision flats, and now we're getting into spheres as well. We also added a coating division, and like I mentioned, all material has some type of reflection or transmission based on the index of that material, basically kind of like the impurities inside it. We add coatings to it to enhance upon what it can already do. And then the service center as well, we do high-end precision grinding, machining, a lot of CNC machining, Haas machines and stuff like that, with extremely high quality products, and real fast turnaround. So United Lens today, we've been truly vertically integrated, meaning we can take a big boule of glass, like this big, and make it into whatever the customer wants and give them everything at the end, truly integrated, So it's a one-stop shop kind of thing. We pride ourselves in that, and that's how we can also turn around, because a lot of places have to buy a blank, they have to make it or have someone else make it and then get it coated. And there's also costs associated with that along the line, where if you can just hire a company like United Lens and we do it all at once, you're going to get it cheaper with the same quality, because we can control the process right from the beginning all the way to the end, So we manufacture mirrors, prisms, windows, all kinds of different optical components. And to ensure that it constantly meets our customer specifications, we really put a lot of money into the state-of-the-art interferometry and spectrophotometers. If needed, we do a lot of testing that meets certain requirements that usually like a prime would ask for, like a Raytheon or Lockheed, certain requirements. We can also do salt fog testing, environmental testing. Because even though you put a coating on it, you got to make sure it sticks. You know what I mean? So you got to put it in the humidity. Basically, you're accelerating the life of the optic that you're testing. You're simulating its lifespan, what it will go through in the course of a lifetime. Then you do certain tests, like tape tests, where you try to basically peel the optic off, the coating off. Also soft fog, like if you do a lot of things that might go into submarines, it's going to be salt water involved. So you got to do salt spray and stuff like that, make sure it'll withhold. And again, you're accelerating the life of the optic to make sure it'll hold up during its lifetime. You know, that's pretty extensive testing, but it's all about making sure, and we invest in that to make sure that the customer, you know, you don't want one of our boys and girls overseas or anything like that to have something fail. We don't want a contractor who's trying to test something have it read good when it shouldn't, you know, because you got to take pride in that it's going out there. And our service center, so we'll talk a little about our service center. We do high-end blanks, we do all types of different material, we machine them. We can make pretty much anything. I probably should have brought some stuff, but it's really neat stuff. Basically, we're a machine shop. It's got all kinds of 5-axis machines, 4-axis machines, and we make it. Anything can be done in metals, we can do in glass, which is really cool to see. And then we also have a lot of vision systems because, you know, glass, one, it isn't cheap, and also it breaks, right? So we have a lot of non-contact metrology. It's basically using vision systems. Again, optics go into that to be able to test optics. It's pretty neat. You got to make optics to test optics. So it's a lot of non-contact. If anything, it's very light probe. You guys are probably familiar a little bit with like a CMM, coordinate measuring instrument. Well, this is all done visually using optics focus points, telling the difference of contrast from dark and light, and being able to give you a reading, a dimension based on that contrast of dark and light. And you know, we do that, we invest in heavily in that because we only want to make it once, you know, measure twice, cut once kind of thing. So the molding division is still second to none. The fast turnarounds, our furnaces, we have 36 furnaces, and that can do all different types of glass, all different types of temperatures to be able to make that glass. And also sometimes our customers, we start right from a molded blank because we find it cheaper even for us, and we move on to the service center. And then they manufacture it, or they give it a different finish based on our customers' manufacturing capability. They might not be able to deal with a molded surface, so we're able to add more value to it for our customer to decrease their cost in-house. So that's pretty much United Lens. Now, what I do throughout the day, well, I do a lot of things throughout the day. I do a lot of things throughout the day. So I just kind of did some bullet points, and I guess I'll talk into it. And if you guys have questions on kind of like what I do, well, one, I'm constantly learning, and I didn't put that up there. You know, I probably should have. That should have been like highlighted, bold, you know, flickering. But I'm constantly learning. There isn't a single day I don't go in and I learn something from someone I'm training. Even that's the one fun thing about this industry is it's constant. It's constant. So I do a lot of process writing. Part of my job as a quality manager, I also do process engineering. So I constantly look at, like, we get something from a customer, how are we going to make this? And one of the first things I did when I was at United Lens, I actually went through the whole shop. I actually pulled glass from the blanks and drew circles on the glass to see if we'd core drill it, how much we'd get out of it. So they really took me and put me right from the beginning, which was great because now I could be handed a print and I can make it right from scratch. You know, it's going to go on this saw, it's going to get cut this way, we're going to use this kind of grit based on the customer requirement, it's going to go on this machine to polish it based on its size and thickness. You know, so that's pretty much what you got to do. Then on the quality side of that, I also got to determine what kind of inspection criteria that the customer is requiring, what kind of standards they have that we have to meet, because there's always a requirement and a fulfillment when it comes to, you know, service, right? So you want to make sure you can meet what they fulfill. So I'm constantly looking at what data they need, what kind of testing they need, and then sharing that. First articles are a big portion of what I've been doing lately. Basically what that is we take one part from a lot before we ship it and we analyze that part and scrutinize it. And then we give supporting data to the customer for approval and saying, yep, as long as you guys use the process you made to make this part, the first article, then there's no question we're going to give you more and more parts to do, you know. So that's one of the things I've been doing. Also, as a quality manager or a process engineer, you're constantly auditing what you do. Make sure, can you make it better? Can you make it better? You know, can you save money this way? Can you save somebody, you know, instead of an operator doing this for 2 hours, can you have them do it in an hour and a half? You know, because it makes their job easier as well. That's one thing as a process engineer, is to come up with ways. I always use these two things, right? And I know they might sound silly, but I like them. Is it in their strike zone? When I'm looking at developing processes, developing work areas, is it in their strike zone? And would I want my mother to do it? You know, if I wouldn't want my mother to do it, I wouldn't ask other people to do it. You know, and that's something I wish I could share that with anybody I possibly can, because if you think of it, would I want my mother to do it, you'd be like, wow, I don't want that guy bending over picking up these 5-gallon things or whatnot. So I always try to incorporate that in the things that I do or try to make better. But you only get that way by auditing, right? Constantly looking for improvement, even if it's not in manufacturing, it might be the offices, constantly looking for improvement on paperwork, how can you make it faster, better, and stuff like that. And then, you know, like I said, constant improvement, you know, and then training. You know, I really enjoy training people, teaching them what I know. That's why I'm kind of here, you know. A little nervous doing this, but that's why I'm here, you know. So I constantly like to teach what I know, you know, because people, I'm paying it forward kind of thing. So how I chose this career. Well, I got a funny story about that I'll share with you. So my father's been doing this for almost 30 years, right? So I went and I was working in excavation. My grandfather owned an excavation business, so I drove truck and stuff. I was about ready to, you know, have a family with my wife, and he goes, you know, you should apply here. No rainy days, you know, apply here, work here. So I applied, and they called my father in because he was actually the fabrication manager of the facility, and he goes, well, your son applied. What do you think? He goes, well, there's no question. He's got great integrity. You know, I'll stake my hat on that, life on that. He trained people, he enjoys teaching people, you know, and he basically said all these really nice things about his son, right? You know, like no father would, right? But then they go, well, what do you think? And he goes, but I don't think families should work together. But fortunate for me, they didn't listen to him, so they hired. But he definitely, I was always, you know, when I was in high school, my father does conventional polishing, as we call it, where basically it's like stick machines that go like this. They're not CNC, what I grew up in. We call it the old school method, which is still really neat, you know, really neat. And I remember always seeing him, and he'd always be squirting water, because you got to, even though he's polishing these lenses using pitch and stuff, you got to always make sure it's wet, you know. And you don't want it too wet, because you want to make sure you're removing material. You don't want it too dry, because then you'll fracture it or cause, you know, all these fun things. So I used to always think you'd just be squirting water all day, you know what I mean? And it wasn't until I actually got my first introduction in optics, like, man, he did a little bit more in squirting water. Of course, when I went there, I used to joke around. He used to go like this, underneath his arm, squirting water on stuff. So, you know, he really got me started here. I learned a lot from him. Never thought I'd be working with him, alongside him, but so it was pretty cool. And then the learning never stops, you know what I mean? Hopefully, you know, I learned something from doing this with you guys. I constantly learn every time I go in, and that's really no lie. You'll find that when you get out there, whether you choose any type of STEM type of workforce, you'll find that it really is, it's learning every day, and you'll be surprised who you learn from. And then people in the industry, the one thing about the optical industry that I found, any seminar I've gone to or any friends, is that it's very small. Even though it's a very big industry, it's still very small. Everybody knows someone that you know. And by that, there's like a family kind of thing, and everyone's willing to teach. I've never seen, unless obviously, you know, it's a special project they can't talk about or anything, but you know, everyone's willing to teach. It's very interesting. You go to these seminars that I've been fortunate to go through with the companies I've worked with, and you know, the guy who's teaching the class is the same guy you're talking with at dinner the next night. It's very approachable, very skill sharing is very critical. So I think that is all I got. You know, believe it or not. You know,